Hi there. Today we're looking at two questions from the 2019 Insight Exam 2, and we're going to look at the first two questions from the extended response section. So question 1 says, consider the function gx as expressed there, given that f-x equals gx and f0 equals -1. Show that fx equals 1/3 x to the power 4 minus 1/3 x cubed minus x squared minus 1. Before we get into this, I would just make everyone aware that what we would want to do here is we'd want to use our calculator as much as possible, so use the CAS technology. And what we would be doing is we would be defining what gx is to make sure that we're getting what we need. If we then want to have a look at what fx is, given that f-x equals gx, fx would be the integral of gx, which I'm just going to write out in its full form. And what we get here is we get 1/3 x to the power of 4 minus 1/3 x cubed minus x squared plus c. We're then going to note that f0 equals -1. So f0 equals -1. Therefore, we can say that fx is going to equal 1/3 x to the 4 minus 1/3 x cubed minus x squared minus 1, meaning that our c value is just -1. The second part then says the graph of y equals fx has stationary points at x equals 0 and 2 other points. So, and find these other points and put them in this form. So what we're going to do here is we're going to say that f-x equals 0 because that's going to give us our stationary points. This could also be expressed as or gx equaling 0. Then when we solve it, so this is like saying 3x cubed minus x squared minus 2x equaling 0. We get x equals 0 as one result, but that's not the result that we're after. And we get two other results of 3 plus or minus square root of 105 over 8. And this is the result that we want to express to answer the question. Then in part B, it's saying the diagram below shows parts of the graph of fx and the tangent L. So L is the line going through the graph, to the graph at x equals 1. The tangent crosses the point at A using the equation. Find the equation of the tangent L. So we're trying to find the tangent of this L. What we're going to do here is we're going to use CAS to solve this, and we're going to use the tangent line function. And remember, we would have defined what fx equals, and we're going to say x1, and this gives us a value of y equals -5x over 3 minus 1/3. There's our tangent line. Then it says state the coordinate of point A. So what we're saying is we're going to say that this line, -5x on 3 minus 1/3, is going to equal fx. We get two answers to this. We get x equals -2 and x equals 1. Obviously, we refer to our graph here. This is going to be -2. So now what we need to do is we're going to say f -2 equals 3. Therefore, A is at -2, 3. And then the next question says, find the bounded area between the tangent of L and y equals fx. So we're going to use our lower limit as -2, our upper limit as 1. Okay, remember, because 1 will be here, -2 is there, 1 is there. Obviously, this gradient function, or sorry, the line or the tangent L is atop of the other function. So we're going to say negative 5 on 3x minus a third minus fx, which is a function of fx dx. Use our calculator and we get 81 on 20, and we should really write units squared. We don't know what the units are, but it should be units squared. Then in C, it says the tangent k to fx at b, where b is the third quadrant, has a gradient of 7 on 12 and crosses the x-axis at C. Find the coordinates of b and c. So what we have here is f dash x is going to equal 7 on 12. We then try to solve what that will be. When solving it, we find x is going to be negative half and x equals 7 on 4. Obviously, if we're looking for part B, okay, that's going to be negative a half. So we're going to say f negative a half, find what that is in the calculator, negative 19 on 6. Therefore, not D, but B belongs to negative a half, negative 19 on 6. That's that coordinate. Then we want to find what C is going to be. So what we're going to do here is we're going to use CAS again. And we're going to say solve, and we're going to say the tangent line. So we're going to find an expression for the tangent line. And we're going to say fx, x, and negative a half. Okay, because that's where the tangent is occurring. And we're going to say equals 0 and find what the x coordinate is going to be. This x coordinate ends up being 43 on 28. Therefore, C is going to be at 43 on 28, 0. Okay. Then it says there is another tangent F that is parallel to the line, parallel to the tangent K. Find the equation of this tangent. All right, so if we're thinking about this tangent, we're going to say a couple of things about it. One, because it's parallel, the gradient is going to be equal to 7 on 12, because it's parallel, same gradient, and has the property that x equals 7 on 4, because that's where it's crossing. Okay, so 7 on 4, and we found that previously, so we're going to use our tangent line. And we're going to say fx, x, 7 on 4. And we're going to get y equals 7x on 12, which is what we were wanting. And then we get a value of 2,875 on 768. Okay, an obscure value, but nonetheless, that gives us our tangent line. Then we come to determine the acute angle between the two lines. Okay, so what we're going to say is our angle is inverse tan 7 on 12 minus inverse tan negative 5 and 3, which was the first tangent that we found. And this comes out to 89.29 degrees. Now, just be mindful that your calculator is on the right settings. For this equation, there is a rule that may be a handy rule for everyone to know. So, a rule for finding the acute angle between two lines. Okay, and it's all based on the gradient of the two lines. And the rule is this, that the angle will be equal to tan m2 minus tan m1. And there is a condition here that m2 has to be greater than m1. So you use the bigger gradient first, and then you minus the smaller gradient. So you have to make sure that this is just a handy rule to know, and something that will always give the acute angle. Okay, now looking at question 2, completely new question. We have f with a set domain 0 to 10, and this function fx, and the graph is shown below. State the interval for which the graph is strictly increasing. Like I said previously, we're going to define this function in our calculator and then use it as so. So what we're looking for is f dash x equaling 0. So where are the turning points or stationary points? So x equals 0 and x equals 4. Therefore, for strictly increasing, x is going to belong to 0 inclusive to 4. Remember, when we talk about strictly increasing or decreasing, we use inclusive brackets, okay? They're not exclusive. That's different if we talked about where the gradient's positive, but for strictly increasing, we use inclusive brackets. Then our next part is to the points A and B are labelled on the diagram. So we have A and B there. The gradient of the line which passes through A and B. So we want to find the gradient of the line that passes through these. So this line going through them, we want to find what that gradient's going to be. We're going to say here that M equals F8 minus F2. The difference between the 2 points in terms of x is going to be 6. And if we use our calculator, we get 32 3e to the 4 on 2 3e. Okay. Then our next question is determine the values for which f dash x is equal to m. Give your answer correct to 3 decimal places. So what we're going to do is we're going to say, obviously we're going to solve f dash x equaling this value. Okay, and we get a couple of responses. We get x equals negative 0.024, x equaling 4.194, and x equaling 14.7. Now, just note here, only one of those are existing in the domain that's expressed. So we say here that x equals 4.194. All right. So the next part is let G have a domain of all real numbers and Gx equaling x squared, and H is D to some domain, we don't know what that is, hxfx, where D is the largest domain for which H is defined. So the first thing that we're going to have a look here is, does the range of G belong to the domain of F? And we're just going to expect that to see if there's any restrictions that we need to be aware of. So we've got 0 to infinity, that's the range of G. Okay, does that belong to 0 and 10? Yes, it does. So this is true. So we can proceed forward. And therefore what we're going to say is the range of G has to equal 0 to 10. And remembering that Gx equals x squared. So therefore domain of G, which is also the domain of H, will equal negative root 10 to root 10. And that's come about because if I take negative root 10, so for example, if I take negative root 10 and I square it, I get 10. And likewise, if I take root 10 and I square it, I get 10 again. And everywhere in between these two values, I will get this range. So that's why our domain is set as so. Then it says find h dash x. So again, use cas. Okay, so we're going to, use the cas to find what it is. And h dash x is going to equal 4x3 minus x5. So this is all found on the calculator. Minus x squared on 2. Okay, easy done. And then they say to plot h dash x. Now, you're going to use your calculator to do this, and our calculator is going to give a response that looks like so, and we can find specific points in here. Okay, so I'm just putting these points in. I'll talk about two crucial points in this mix, but the calculator has shown me what I want to have in here. Okay, and okay, and our graph looks something like this. And remember, I've already seen what this graph looks like from the calculator. Okay, and we have, I want to label my intercepts, and I want to label my endpoints. Now, according to my graph, I have 3.16 and 1.28, and I'll talk about these two endpoints, which are really important. So these are my endpoints. Now, the reason why I'm focusing on these endpoints is because these negative 3.16 and 3.16, they're related to the restricted domain. So if I restrict h within a specific domain, then its derivative function has to be restricted as well. And that's what we need to focus on. Keep up the good work, and I hope this helped.